Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of optimization. So as per the problem, what are the dimensions of a rectangle with an area of 64 meters square and the smallest possible perimeter? So we have to find the length and width of a rectangle such that its area is 64 meters square and the perimeter of the rectangle is a minimum value. So the first step is to draw a rectangle. Let's assume the length of this rectangle is L, the width is W. As per the problem, the area of this rectangle is 64 meters square. The formula for area is length times width. So this is the equation for the area. We have to find the dimensions for the smallest possible perimeter. Next, we should write the equation for perimeter of this rectangle. This is the formula for perimeter of a rectangle. Now we have to find the derivative for this perimeter function to find the dimensions for the smallest possible perimeter. This perimeter equation is based on two variables, length and width. We should use the area equation to do substitution for one of these variables. We can isolate L from the area equation by dividing both sides by W. Now we can do the substitution for L in the perimeter equation. Next, we should find the derivative of this perimeter function and set it equal to 0 because we want to find the values of W at which the tangent is horizontal, because the tangent will be horizontal at the minimum points in the perimeter function, and we are interested in the minimum point because we have to find the smallest possible perimeter. In order to find the derivative, we should modify this perimeter equation by moving the W from the denominator to the numerator, because that will make it easy to find the derivative. Now we can find the derivative. In the first term, 128 is the coefficient, so it will stay as it is. Now we can use power rule to find the derivative of W to the power -1. As per the power rule, we should move the exponent to the front of the term and subtract 1 from the exponent. In the second term, 2 is the coefficient, so it will stay as it is, and the derivative of W is 1. Now we can set the derivative equal to 0. Now we can solve for W by moving the fraction -128 over W squared to the left side, and that will make the fraction positive. Now we can cross multiply the denominator W squared. Now we can divide both sides by 2. Now we can apply square root to both sides. I get W equals plus minus 8. Now we know that width cannot be a negative number, so the valid answer is W equals 8. Now we should verify that the perimeter is a minimum value at W equals 8, so we can use the first derivative test, and for that we can use the number line method. We have to check whether the function is increasing or decreasing on the left and the right hand side of 8. So we'll have to use a test value. On the left side, we can use the test value 7.5. On the right side, we can use the test value 8.5. So we should sub in these test values in the derivative of the perimeter function. So I'll write the derivative equation. So let's start with the test value 7.5. Now we can evaluate this expression. So I get a negative value. That means on the left side of W equals 8, the function is decreasing. The slope of the tangent is negative. Now we can use the test value 8.5. So I get a positive value. That means the function is increasing on the right side of W equals 8. That means the perimeter has a minimum value at W equals 8. We have to find the dimensions. So we have one dimension equals 8 meters. Next we can find the length of the rectangle by subbing in W as 8 in the area equation. I get L equals 8 meters. So this is the length of the rectangle. So these are the dimensions that give the smallest possible perimeter. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.